Hi there, this is Richard Walker from Lucidate. Welcome to this fourth video in this series on Ethereum. In the first video, we discussed the purpose and unique attributes of the Ethereum blockchain. The second video introduced smart contracts and the Solidity programming language. Our most recent video in this series looked at cryptocurrencies and how to build your own token or coin on the Ethereum blockchain. In this video, we're going to look at NFTs, Non Fungible Tokens. In this video, we'll discuss the concept of NFTs as deeds or claims. We'll explore the Ethereum NFT specification called ERC721. We'll look at a novel solution for storing large amounts of data securely off-chain. This solution is called IPFS, which stands for Inter-Planetary File System. We'll then discuss what the future might hold for NFTs, both as records of ownership in virtual worlds, as well as more grounded applications in real-world capital markets. Blockchains can be regarded as technology that allow you to 100% agree about stuff with strangers on the internet. That stuff is provable and verifiable data. It's provable and verifiable using techniques from cryptography. That data can be about anything. For instance, that data can be about ownership. Strangers on the internet can therefore 100% agree on who owns what. NFTs are a way of recording ownership, or perhaps another way is identifying who has digital rights to something. The original designers of the Ethereum NFT standard, this is called ERC721, thought of these tokens as rights, deeds, or titles, but the name Non Fungible Tokens was considered to have broader applicability, and this name has stuck. We're used to having rights and claims conferred by assets and registries. A driving license gives us a right to drive, a passport, a right to travel. Land registries and mining claims confer ownership rights over real estate. Each of these rights and claims is unique. Some may be traded, real estate and mining rights may be sold, others are unique to an individual. Clearly, a passport or a driving license for an individual may be revoked in the case of some kind of wrongdoing. The original developers of the ERC721 standard considered use cases of NFTs being owned and transacted directly between individuals, as well as consignment to third-party brokers, wallets, exchanges or auctioneers, which the designers referred to as operators. They proposed tokens to represent ownership over digital or physical assets. They considered physical property, houses, artwork by old masters, virtual collectibles, digital artwork, collectible cards, financial claims, loans, burdens, and other responsibilities. They stated that in general, all houses are distinct and no two cat videos are alike. NFTs are distinguishable, and one must be able to track the ownership of each one separately. So we have data describing ownership, and we'll get into how the ERC 721 standard does that shortly. But what is it that is owned? Well, that's data as well. Clearly this could be anything: a claim on cash flows for loan servicing, rights to a parcel of real estate in a land registry. To date, most, and for most read nearly all, NFTs have been linked to digital art, largely images, some movies, and a smattering of songs. And these have grabbed the attention, particularly given the eye-watering amounts that CryptoPunks, Bored Apes, CryptoKitties, and art from NFT pioneers like Beeple have generated. In this video, we'll try to ignore the hype and the boom-bust cycle of NFT valuations. There are plenty of other places to go to get that kind of information. Here, we'll take a peek under the hood to see what's going on. There are lots of useful applications of this technology, as we shall see. First, we need to confront a very real commercial problem. Storing any information on Ethereum costs gas. The more information we store, the more gas we consume. Images, songs, and videos have a huge data footprint. We need a gas-efficient way to store data that's immutable and decentralized. If bad actors can alter the data, you can wave farewell to your digital asset. If it's stored centrally and that central service fails, then you've either temporarily or permanently lost the thing that you thought you had digital rights to. To solve both these problems, enter IPFS, or Inter-Planetary File System. This is a decentralized, content-addressed file system. Decentralized means that it runs on multiple peer-to-peer nodes. These nodes build in storage redundancy. If a node requests a file, then it will keep its own local copy. If a node goes offline, then other nodes have their own copy of the file. This also speeds up file access, as you can retrieve different parts of a large file simultaneously from multiple nodes in a torrent-like fashion. Content addressable storage means that you don't ask for where a file is with a URL. You ask for what it is. The what is represented by a hash. Recalculating the hash when the file is retrieved verifies the integrity of the file. If the check fails, then the file has been modified. Each file has a unique 24-character hash ID called the Content ID, or CID. This CID can be efficiently stored on the Ethereum blockchain, minimizing gas costs. One way to think of the relationship between the Ethereum blockchain and IPFS is using a library analogy. A library has books and a catalogue. The catalogue doesn't contain the contents of the book, but it contains metadata and shows where the book may be retrieved. In this way, the Ethereum blockchain is analogous to the catalogue, while IPFS is analogous to the books on the shelves. One of Lucidate's logos is a gold logo with a slate background. It's been added to IPFS. Its CID is shown on the screen and is in the video description. If you install IPFS on your machine, then you can use this Content ID to view the file. If the logo were altered in any way, then the CID would not match. Now, let's take a look at the ERC721 specification. As with the ERC20 from the previous video, we have a name and a symbol. 3 mappings establish the ownership of the NFT and handle transfer of ownership. Items might be one of a kind, like the Mona Lisa or Jerry Garcia's Wolf guitar, or they might be a limited edition run of 200 Kanye West Yeezy sneakers. To support limited edition style tokens, the ERC721 implements a unique counter for each item in that limited edition. This not only proves scarcity, but it also explicitly links a unique token owner to the specific token that they own. So as we said, there are 3 mappings. The first mapping simply keeps a count of the number of these tokens that a token owner owns. This is a mapping between an address and an integer. We then have 2 mappings, a mapping from the token owner to the ID of the token that they own, and this is called owned tokens, and a further mapping from the token ID itself to the address of the owner that owns it, and this is called token owner. At first, this seems odd. We're duplicating a mapping. Why have 2 mappings instead of 1? The reason is to reduce gas usage. While it's perfectly possible to maintain and transfer ownership with just the owned tokens mapping, finding an owner using the token ID would involve looping through the entire mapping. And this is certainly possible in Solidity, but it's very, very inefficient. much better to use two mappings. NFTs can be transferred in the same way as ERC20 coins. Two workflow methods are supported. Firstly, a simple one. Directly transfer the token from the spender to the recipient. Secondly, the more complex third-party workflow that allows an external smart contract, e.g. an NFT exchange, to transfer the NFTs on behalf of the owner. This requires an analogous approval step as for the third-party transfer of ERC20s. Please see the ERC20 video if you're unfamiliar with these two transfer workflows. So once again, the specification is pretty straightforward. If you'd like to see Lucidate's implementation of the ERC721, you can use the Gurley Etherscan. It's at the address on your screen and in the description below to save you typing this in. Now, this would be a good point to mention something that we glossed over in the ERC20 video. Don't write these types of contracts from scratch. For these contracts, working examples exist that you can fork and then add to with your own functionality. This particular contract has been forked from the Open Zeppelin ERC721 template. Firms like Open Zeppelin have a bunch of outstanding developers and QA engineers. They also encourage third-party hackers to break their code by offering bounties for successful hacks. Therefore, all the code comes pre-built, pre-tested and pre-battle scarred. You can add your own functionality to it, knowing that you're building on rock-solid foundations. Check out Open Zeppelin's Solidity library of reusable and secure smart contracts. Once you've written a contract, you can deploy it and mint tokens. You can sell these directly to others or list them on exchanges like OpenSea. As with all things blockchain, everything is provable, auditable, and in clear text. You can click on links to go and see the code that was used to mint this NFT. So where next for NFTs? Frankly, NFTs have exposed a wrinkle in the Ethereum ecosystem, that of gas costs. It would have happened anyway. The hype around NFTs served as the catalyst. Frankly, the more people that are deploying contracts, minting coins and tokens, and generally invoking state-changing functions on the blockchain, the more compute resources become scarce and the more gas price increases. At the same time, the price of ETH has increased relative to fiat currencies like the dollar, pound and euro. While it's off its highs, it's still way above the price when the ERC721 standard was released. When once one could have deployed a token for a few pennies or units of dollars, it now might cost upwards of several hundreds of dollars, depending on the prevailing gas costs at the time of day you're deploying. The merge will help with this. The move to proof of stake will reduce energy consumption. The sharding of the blockchain will reduce gas costs. Both of these changes are welcome. With reasonable gas costs, one can expect many uses of NFTs in both the real world and in virtual worlds too. Here is Mr. Spigot. He's waving. You can wave back if you like. This is my avatar in Decentraland. Mr. Spigot isn't wearing limited edition Yeezy sneakers, nor does he have a licensed Jerry Garcia Wolf guitar around his neck, but he could. These could all be traded as NFTs in this virtual reality. Parcels of 16 meter by 16 meter real estate are bought and sold as NFTs in Decentraland. Intuitively, some parcels will be worth more than others. Land near a popular casino might be able to sell advertising space, for instance. So as well as virtual guitars and fancy footwear, you can own digital art as an NFT. Here, Mr. Spigot is strolling through a public NFT art gallery. But imagine the flex of hanging up a crypto kitty or a bored ape that you own in your own DC crib. I'll be honest, Decentraland is not for me, at least not yet. The interface is clunky and there's not enough serious content to get me engaged. But people once said exactly the same thing about the internet. Frankly, the premise of Decentraland and other virtual realities are sound. Making the internet operate more like the real world rather than a piece of paper or a screen is a compelling idea. And there are plenty of users of things like World of Warcraft or Minecraft that disagree with my rejection of virtual reality. I've no doubt that things will get more compelling in various metaverses, but for me, it isn't quite there, at least for now. What about actual reality? Well, if we start with the premise that blockchain allows strangers to agree about stuff on the internet, then NFTs can help enormously. Yes, you have to solve the gas problem. But think about hotel rooms or Airbnb rentals. Each one of these is unique and they can be represented as NFTs. With some NFC technology, that's near field communications, in your phone or watch, you would be authenticated to unlock your Airbnb or hotel room for the duration of your stay if you were the owner of the NFT. Instead of renting the room, you could own the room. A hotel room or Airbnb property generates cash flows as rental income. These cash flows can be sold by the originator in the form of an NFT. Once you've done that, it's a simple step to buy other cash flow streams like mortgages or other debt obligations. When Louis Ranieri and Larry Fink created the first collateralized mortgage obligation in 1983, they had to put multiple mortgages into a package. Now, solve the Ethereum gas problem, and there's no reason why you couldn't do that with a single mortgage as an NFT, or even offer fractional ownership of the cash flows of a single mortgage. As with all things crypto, just because these things are possible, it doesn't necessarily make them desirable. But being able to prove to strangers that you own something like a stream of cash flows without expensive registration or legal drafting opens up huge possibilities in capital markets. This is Richard Walker from Lucidate. In this video, we've looked at NFTs. We've viewed them through the lens of a deed or a claim. We've looked at some structures such as IPFS that allows information to be securely stored off-chain in a decentralized repository. We've looked at the NFT spec on Ethereum called ERC721. We've seen how this can store unique assets or limited edition collectibles. We've then explored uses of NFTs, both in virtual worlds like Decentraland, as well as in practical, real-world examples. Please join me in the next video where we'll continue this debate and look not just at the future of NFTs, but at the future of the whole Ethereum blockchain.